Okay, dropping back, everybody. So I prepare for the video. Okay. So I must first. Okay, everybody start dropping back. We wait now a minute till everybody is back. So I'm going to show you a video about a gigantic vacuum chamber. What is a vacuum? A vacuum is when we are in the room, there's always air around us. If there's no air, we could not survive, okay? But what will happen if I suck all the air out? There is no air in the room, and they made in a place, they made the biggest vacuum chamber in the world, and they made an experiment in there with a bowling ball and feathers. So, and this is something I like to show you because it's very interesting to see. Okay, I make a desktop change and go on share. So now you see here a big hole. Wait, I must make first sound on and optimize the video. Okay, let's see. You can hear the sound, right?
This is NASA's Space Power Facility near Cleveland, Ohio, and it is the world's biggest vacuum chamber. It's used to test spacecraft in the conditions of outer space. And
can you hear the sound?
Yes.
Okay. Good, I play it.
It does that by pumping out the 30 tons of air in this chamber until there are about 2 grams left. And it's kind of got an eccentric construction, which is part of its history. It was built in the 1960s as a nuclear test facility to test nuclear propulsion systems. And that meant that they built it out of aluminium to make the radiation easier to deal with. Aluminium is not the best thing, the strongest material to build a vacuum chamber out of. So they built an outer concrete skin, which is part radiation shielding and part an external pressure vessel, so that this thing can take the force that's present on the outside when it's pumped out to the conditions of outer space. Galileo's experiment was simple. He took a heavy object and a light one and dropped them at the same time to see which fell fastest. Now in this case, the feathers fell to the ground at a slower rate than the bowling ball because of air resistance. So in order to see the true nature of gravity, we have to remove the air. It takes 3 hours to pump out the 800,000 cubic feet of air from the chamber.
Okay, we dropped 2 millitorr in the last 30 minutes.
But once it's complete, there's a near perfect vacuum inside.
6104 manual, 10% open. Station 1, go for drop. PCV 30-1, pressure set point at 240 psi. We are go for drop.
10, 9, 8, 7, 6, 5, 4. Cameras on. 2, 1. Release.
Exactly.
Look at that.
Exactly. They came down exactly the same. Wow.
Look.
Watch right there. Look at how they hit right there.
Exactly.
You're back on the side. A little bit closer
Exactly
to
the
that.
same.
Feathers don't move, nothing.
Look at that. That's just brilliant. Isaac Newton would say that the ball and the feather fall because there's a force
Hello guys, oi.
Okay, what do you think, MJ?
Yes, teacher.
What do you think when you see the video for the bowling ball fell absolutely same the feathers because of no oxygen in the room? What do you
I
think?
was shocked.
You are shocked. Why? This is the magic of gravity. Nobody 100% can explain gravity. So the bowling ball and the feathers fell exactly the same speed down on the floor because no oxygen in the room. So the feathers are slower than the bowling ball because the feathers have more air resistance. That means they block the air, block much more on the feathers than on the bowling ball. The bowling ball is smooth, but when you see as a feather, as example, and you look the feather under a microscope, make feather. So when you see the feather, everybody know what is a feather. So already a feather. I make this a little bit bigger in another window. Then the feather has much more air resistance than the bowling ball. That means block the air, stop the air. So this is nothing to do with the weight, nothing to do with the gravity. The gravity pull all boats down on the floor, but the air in the room block the feather more than the bowling ball. So if I suck all air out from the room, there is no air in the room, then all both subjects fell the same way. Doesn't matter it's a people, doesn't matter it is a bowling ball, doesn't matter it's a car. All both get pulled down the same speed. Doesn't matter what weight it is. And this is fantastic to watch. So it's very simple. Everybody can take as example a penny, a coin. You take 2 coins. You take 2 1-baht coins and a water bottle. So you open the water bottle, you take the coin over the water bottle, and on the other side, the coin away from the water bottle and let them fall at the same time. So the coin in the air goes faster on the floor than the coin in the water because resistance in the water. So it has nothing to do with the weight. And this has to do with matter. To understand everything around us is about matter. So when we have this example here, put a small cup of water into a freezer. After 2 hours, what happened to the water? Let's see.
Teacher,
Yes?
can you give me the definition of matter?
The definition of matter is a mixture of different, okay. You have number 1. The matter, the state of matter, okay. Look here. I give it you like that. if you like to write it down. Definition, oops, definition of matter. Here. Wait, I make it bigger so you can see it better. Here you go. Can you read that? Right, yeah. Physical substances in general. So this is the definition of matter. So the definition of matter is you have the smallest one is an atom. You go bigger, you have the molecule, and you go bigger, then you have the matter. So the smallest in the surrounding is the atom. So everything, every matter is made out of atoms. Every molecule is made out of atoms. So somebody is writing here. Just a moment. Cartoon. Cartoon, we are in lesson now. You not need to send. Oi. Okay. So go back. But all this matter, what we have, like it is, as example, it is water, it is oxygen, it is oil. So all this matter around us, the matter changes by pressure and temperature. So an easy example we have here, put a small cup of water into the freezer. After 2 hours, what happens to the water? Look, Job, put a small cup of water into the freezer. After 2 hours, what happens to the water? What happens to the water if you put water into the freezer?
I.
Say it again.
I.
ไอตาแปลว่าอะไร Look, Job, I not too joking with you. I only teach you. Okay? ไอแปลว่าตาโอเคไหม ไอแปลว่าตา
ICE.
ice. Okay? Ice. So water changes. Ice. So we have there change the state of matter into solid. Okay? So I write it like that because it's better to understand, because ice is solid. So water changes into ice, change the state of matter.
What page, teacher?
Do you have the reading book? มีไหม
Yeah.
For page number 50, 50. Page number 50.
Teacher, I don't have the reading book, but I have the working book.
No problem. We work together on the reading book and we go on the workbook after, okay? So we have there, what state of matter has the water changed into? State of solid matter. So the state of matter is solid, okay? What did we do to make the change into state of matter? So that what did we do? What did we do? I see unsealing, but I not see un. Heidi, what did we do? What did we do to make the change in state of matter? What did we do?
I don't know.
Oh, You know. Water goes into ice. How you do that? How you make water into ice? Everybody know, you know it too. How you make water into ice? Yeah, put it in the freezer, right? ตู้เย็น ใช่ไหม? Yeah, and what is in ตู้เย็น? What is in there? What is in the cool? Correct. But how do we call cold and hot? How do we call that?
Put out. Warm.
Temperature. Change the temperature. Temperature is make something, same as example we have now in my room. I have about 28 degrees in my room. So if I heat up water to 90 degrees Celsius, 100 degrees Celsius, I get gas. If I cool it down to 0 degrees, I get what? What do I get when I cool down water to 0 degrees? Then I get what do I get when I cool it down to 0 degrees?
Temperature cool down.
Yeah, the temperature goes down, but the state of matter changes into ice. So lower the temperature of 0 degrees Celsius. So what did we do to make the change of the matter? So lower the temperature of 0 degrees Celsius. Made the water solid. Okay. You understand? 0 degrees, solid. 100 degrees, gas. Between 0 and 100 degrees, we have liquid. So all matter around us is in the way of solid, liquid, and matter. Solid, liquid, and gas. So are there any substances formed in this process? No. Nope. Okay. Can you reverse the change? Yes. So what does it mean? What does it mean as example? Are there, say again.
Nothing. It's
Okay. So are there any new substances formed? That means, is the water different? No, it is not different. Just the state of matter changes. That means the water went into solid, the liquid went into solid, or the liquid went into gas. So if something goes into gas, I can change it back into liquid. If something is liquid, I can change it back into solid. So I can make these 3 changes of matter I can do. We say they're physical changes. Physical changes I can easily change. Chemical changes I can't easily change. So as example, physical change, we see here. Melting ice, boiling water. These both are physical changes. Okay. So we have here physical changes. This both is a physical change. I can easily change. I make it hotter. It becomes gas. I cool it down. It goes liquid again. I cool it down more. It goes into ice. So, but we have here as example, this here is a chemical change. So burning something down, it changed the material too. So, but this I cannot reverse. So if I burn, as example, a matchstick, and then I cannot change it to make it a matchstick again. It is not possible. Heidi, what is so funny? What cam do you see? I know An's cam is funny. Okay. So boil some water in a pot. What do you see? Boil some water. What do you see? What happened when you boil water on a pot? What do you see? What do you see when you boil water? How about you, MJ? What do you see when you boil water?
Vapor.
Vapor. Vapor, yes and no. Vapor can be cold. Vapor can be cold too. As example, you make ultrasound onto water, then you get water vapor. Or when you spray water, say very fine, then you get also water vapor. But we call that not water vapor, we call it, can you read it?
Water system.
Water steam. Water steam. So when you cool, when we heat up water, we get water steam. The water steam. So that means the water changes its matter into gas. So we get there water steam. Boil water in a pot. What do you get? Water steam. What is? Matter, state of matter. But okay, wait. Gas. Oops. Is gas. So what state of matter has the water changed into? The state of matter is gas. So what did we do to make the change of the state of matter? So what did we do? Now I ask Heidi again. Now I ask Ploy. Ploy, she has a nice cute piggy in the background. Ploy, when I get water steam, so boil water in a pot, what do you see? Water steam. What state of matter has the water changed into? Is the state of matter is gas. What did you do to make the change of the matter? What did you do? What did you do to get this here? What did you do? What did you do to get steam? What do you have to do to get steam? What do you do? What do you do? Ploy? What did you do for you get steam? Okay.
Did you get an answer?
Yes, answer yes.
We changed liquid to gas.
The question is, what did you do to make the change of the state of matter? So you have there, heat up. Heat up the liquid, change the matter into gas. Okay, so heat up a liquid, change it into gas. Same, you have gold. Gold, when you have it on your arm or on your finger or around your neck, gold is solid. When I heat it up, gold goes into liquid. When I heat it more up, the gold goes into gas. I can change it again back. The liquid gold, I can make again liquid The liquid gold I can make again into solid gold by cool it down. Okay. So when you heat up water, are there any new substances made? No. Nope. Can you reverse the change? Yes. You can reverse it. So if you have gas, water, gas, water, steam, you can change it again into liquid by cool it down. Cool it down, goes into the state of liquid. Cool it more down, it goes into solid. Okay. So if you have, as example, a dry spoon above a pan, as example, where it's boiling water in there, what will happen? Place a dry spoon above a hot pot. What do you see on the spoon? What is the state of matter? What do you see? Faye. Faye. I know it's หมดเวลา I know it is 3 o'clock. Faye, are you okay?
Yeah.
Okay. So if you take a spoon above a cooking pot with water, what will happen to the spoon? Does the spoon get wet? เปียกไหม?
Yes.
Yes, because the water steam changes again into liquid by the spoon. Okay. So let me see here. We go down here. Okay. So we have here page number 37 and page number 38. So read the book on these pages 37 and 38, 37 and 38. You go here, you start by the page number 34. Page number 34. Read you down till page number 37. Make the exercise in 37. Heat and cooling. 37 and 38. 37 and 38. Small homework. Okay? Good. หมดเวลา ladies and gentlemen. I see you again tomorrow.
Good afternoon.
Good afternoon. Goodbye, everybody. Goodbye. Goodbye. Good afternoon. Bye-bye.
Thank you, teacher.
Thank you. Bye-bye.